So thank you for joining this workshop. So Dr. Keon Woo Lee has studied physical chemistry in Korea Advanced Institute of Science and Technology and received his doctorate also at this institute in physical chemistry in 2002. And he's working as a senior manager, product development and battery solutions at Henkel and Düsseldorf. And he will share us today a talk on on how we can establish competent cell production capacity in Europe.
Thank you, Felix. Um, First of all, I'm really sorry that I cannot make it there. But typically, I really like to create a bond through the interactive environment. But today, I was just, okay. The reality is not that easy. So I'm here on an online. But before just jumping into the topic, I really want to state this: I'm not the market analyst. I'm not the and market expert like you know the consultancies, and also I'm not the machinery expert. I'm pretty much not even the expert, but I call myself as a generalist of materials, better materials, because I used to work for the like chemical company which was making the actually which was like manufacturing started manufacturing of the battery lithium-ion batteries first time in Korea. And 3 years ago, I just left that Korean company to join the Henkel. So I'm pretty much the generalist. And today I'm going to talk about a little bit provocative stories because this is like afternoon session. So just feel free to listen to it. Don't stay critic because some statement would be a little bit provocative. But today I really want to talk about very freely talk about how we can establish the competent. Competent means like really competing this a very good cell production capacity in Europe. So let's take a look at the current picture of the Europe. Everybody is looking at this map, right? There are a lot of like really a lot of like projects which are which are for cell manufacturing inside Europe. And this is the picture which was recently published by Better News. So there are still a lot of like projects, and the total capacity just just like until the 2030 something, you can expect actually 2 terawatt hour. But if you take a little bit deeper look, the numbers start to change. So there are some projects that are already on hold or delayed in Europe. First, because of the slowdown in the like the front end industry. And secondly, the some like some stresses from the other like regional like other continent. You can see that. So this year is pretty tough because we are seeing some sort of like slowing down of the growth because these numbers are actually are estimated. These numbers for this year was estimated last year, but this year I'm pretty confident that the numbers are much slower, much lower than this. And why? Because and I'm sorry, but and this kind of like slowing down affects all other industries because they have to hedge the risk, and then you can see not really promising uses here and there, starting from the asphalt who canceled the plan to build a better factory here in Europe, and also you can see some not really good news about the the other companies. And the ACC also just put on hold of some projects. So this is a pretty difficult time. And this is a massive one. And you can see some concerns about the future capacity. But I don't think it's a really bad sign because like I see in the past when I just got here in Europe, I saw all those like crazy numbers, and I thought like, okay, that's just too much because like demand is demand, and the capacity is capacity. They have to match, but the whole overall like capacity actually did not match. The sum of the whole capacity did not match with the demand in the market, and also the supply chain maturity was not there. So I think I don't think it's a slowdown. I think it's a bit more about the market being realistic or market being more responsive to the customers. So when it comes to the risk hatch, and you can see actually the almost the half of the capacity because of the slow consumer uptake of the electric vehicles and also the competition from the Chinese cell manufacturers. So today's focus is two things. The first, how we can do it better. Oh, actually, just one, to be honest, because how to do it better, we have to do it differently. So I'm going to talk about how we can do it better by doing it differently. And also, there is another news about the Northvolt, and but this is a very not good, but very harsh the a harsh fact that how difficult it is to build up the capacity, cell production capacity here in Europe. So the Northvolt is struggling. I don't think it's gonna fail, but I really hope that Northvolt will come back to its normal state, and then there are a lot of like other projects that are on hold or delayed or canceled. And there was a this is pretty much provocative. So this one I'm just murmuring like this. And the recently there was an interview. There was an interview between the one company and the CEO of CATL. And they just take a look at the question. Actually, the um, what are the problems? Actually, I cannot recall the exact questions from his side, but he was asking why it is difficult to build the good, decent cell manufacturing capacity here in Europe. And the answers from the CEO of CATL was like were like this. The first, wrong design. Wrong design means like the wrong chemistry or some wrong components or the wrong constitution or wrong architecture inside a cell. And secondly, he made it actually some second answer, but let's do it in a different way. And the secondly is that he was talking about the wrong equipment. Okay, we have a lot of things to do, right? And thirdly, he was mentioning the wrong process too. But actually, I don't think the process and equipment are they're different things. So today I want to address it at the same time. So when it comes to the process, manufacturing process, it's going to be a little bit different. I think a lot of people sitting there, a lot of people on the screen somehow believe those numbers. About 50% for the labor and structural cost. These results are based on a study in 2020, and I also recall these numbers. And when I was in my former company, a former employer, I was a bit like surprised because those numbers are pretty different from what I was handling there. And even very recently, this year, we got this study with a global point of view. And you can see the portion of the structural cost and the processing cost is close to like late 30 or 40%. So if you think it's odd, I mean, you may have some notion about the cell manufacturing processes in Asia. So let's take a look at the very like stimulating numbers now. So this is the number from the Chinese consultancy. I got this information when I was attending the recent the conferences. They're calculating actually the sum of the processing and sales cost is just 26%. Everything else are the materials. Case, copper foil, aluminum foil, electrolyte separator anode, and the cathodic material, and blah blah blah. So all the processing costs including the structure costs plus the sales, like this SG&A, constitutes just 26%. We have to deal with this number. So just let's go back to um, the global point of view. So someone thought that we could have many chances to improve a lot, but this is the harsh reality for our competitor. So our competitor, maybe competitor, or maybe the benchmark partners, and they are based on this cost structure. So material cost is also, here in Europe, if you source from the Asian countries, the material cost will increase, definitely. But just the structure is structure. So even with the increase the prices of all the materials and components, you also have to deal with the increased price tags on your like energy costs and the labors and whatever. Then how can we overcome this? There's actually one small factor that is highly likely neglected. So I really love this article by the Professor Hinkamka. How likely is a teamwork, the result of teamwork, and then he was stressing the scrap rate. Why is it important? You can read the sentence with the red line. So the scrap rates in battery production are high, often around 30% when production starts. But the rate, well, established, and then it goes down to the 5 to 10%. And currently the leading companies are showing the numbers. They are not sharing the numbers, but everybody said like, yeah, it's less than 3% in the fully established and the fully stabilized lines. And typically, it takes 2 to 3 years to get to that limit. So the key to win this race is somehow just one of the keys. So one of the keys is how you can deal with this high scrap rate by starting right, or by providing the right equipment which can find the best conditions as soon as possible. So this is the game of perfection from the start, and also the game of finding the game of the speed to find the right parameters to increase the efficiency to the maximal level. And second part would be interesting because also you can think about the other processes. The dry coating, okay, maybe many of you, or maybe all of you, have heard about this technology because the Tesla made a really big one. But this technology has a longer history and legacy. And by the way, and they started to use it. They just made this technology bigger thing during their battery day until 2028. I think it was 2020. They made this big, and then they just compared the conventional technology with the dry electrode process, and saying they can benefit a lot from this, and that those are the rough numbers that we learned after this presentation by Elon Musk. So this is roughly the you can reduce the 20% of the cost if you switch from wet chemistry to wet process to the dry coating process, and the 50% of CO2 will be gone away. And so this is a very promising technology. But there is a trap, actually. There were a lot of challenges which have not been solved yet. I don't know how much you know about this company's the current status of this company, and the 2 years ago they stated that they started the mass production with the dry coating process. But actually, there was a rumor that this process was used only for the anode side. It was not proven, but this year it was actually this rumor was fully proven by this statement, because they said like first they just posted this on the X saying first prototype Cybertruck with in-house dry cathode 4680 cells. So they have been outsourcing the dry cathode from the outside, and so outsourcing the dry cathode, which means they failed failed to launch this dry process for the cathode when they just started the mass production. But this is odd, right? But all the benefit, and not all, but then 90% of benefit is based on cathode side. But the cathode side was, but the dry electrode process was not used for the cathode side, which means the benefit was gone. Maybe in worst cases, even the benefit was not there yet. Maybe only the disadvantage. Who knows, right? And the to overcome these problems, and then there are some information about the main challenges in dry electrode coating processes. The first one is related to the solid powder formation, which includes the binder system, very unique binder system based on Teflon, which is not good for health and sustainability, but anyhow, they're using it for calendaring. So they are looking for the new binder system. And secondly, the inspection method is very, very critical to see the quality of the dry powder mixture, and also by doing so, you can actually control the quality. So the quality is overarching all cases. And let me focus on this on the left side only, and then you can see the new binders, and you can also see the robust cathode active material. But at the same time, you need a robust roller too. If the cathode active material is not strong enough, it is crush it down to create the side reactions during the use cases. But the cathode active material is based on ceramic, so it's hard enough to hurt the surfaces of the rollers. So you have to find the best balance. I don't know how to solve this problem, but I think that that company that I mentioned is getting there. I mean, just really close to the solution of these problems. And there always is a problem about adhesion between materials, the active materials and the current collectors. And this is the place where Henkel plays a role. And the loss of the first cycle efficiency was really notorious, and many people is working on the over-lithiation or the pre-lithiation technology, and this loss is based on the binder characteristics too. So some people are working on binder system too. So when it comes to the machinery side, I think the second role would make a bit of sense. Okay, sorry. So this is how Henkel helps this dry coating process by providing the coating materials. So our coating material is applied onto the current collector first, and helps the adhesion between the active materials and the current collector. By doing so, you can actually decrease the pressure. For instance, if you want to transfer one active layer onto the current collector, you have to press it hard. But if you use our material, you don't have to. Also, to make the better bonding, you have to increase the temperature too. But if you can increase the interfacial adhesion by using this type of the carbon primer, and you can decrease the temperature too. This is how the Henkel helps our customers realize the dry electrode process for their new lines. Okay, thank you. Did it interest you? Was it interesting for you?
Yes, it was.
Okay,
thank you so much for the talk.
All right, thank you. This is pretty awkward. Okay.
Is there any questions from the audience, either here on site or also online behind me on the screen? Otherwise, I would have a first question. Okay, great. At the beginning of your talk, you said a little bit about production costs. And we then switched a little bit into production technologies. And I think, and it's all about the race. We always say it's a race between Asia and Europe. Do you think we have a chance to win the cost race? Or will it be in the end a technology race where performance counts more than cost? So I see only two chances, two areas that we can actually compete with the Asian manufacturers. The first one is the square rate, the perfection of the lines.
The scrap rate is like huge. If you go to the line which just started to be used, and then you can see a lot of scraps, even anywhere. Absolutely, there is no exception. But if you can decrease it like hell, and then you can actually save a lot of money from the beginning period of time. At the same time, the 1%, 2% is something that we have to address. Labor, no, you cannot control it, because like if you go to the line, there are only a few people. Even in China, it is you cannot see a lot of people in the line. So this is a pretty big misconception. So you have to really focus on the scrap rate. If you can save like 1% or 2%, you can actually start to compete, start in the line. You can stand in the line, which is really close to their product their price tags without subsidy. Sorry, but without subsidy. Subsidy is something else, and I don't want to talk about it. So without subsidy, you can have this edge, but this 2 and 3%, or maybe the 1%, could not be really helpful. The second factor could be the new technologies. Just please, the Germany is the home of the innovation, especially in manufacturing technologies, and I know a lot of great German companies which my colleagues could not replace with other Asian manufacturers. So I think if we just we keep improving or innovating the current technology. For instance, is faster drying with the laser. What if it's successful, and then we can start to get over with the gaps between Asia and Europe. So I have that kind of dream here in Germany.
Thank you very much for the insight and your opinion on that.
Ask from here?
Yeah, I think if you speak loud.
Yeah, so I have a question related to the thing what you discussed in one of your slides, like where you said the wet versus dry process technology. So you said like so in terms of relying on the dry process technology, you can cut down the cost as well as saving energy, but in terms of maybe sacrificing some production challenges. But the question is like now nowadays how the industry is adapting this dry process technology techniques.
So as far as I know, based on the public knowledge, only Tesla is using this. So, and that they're really close to the realization of the cathode active material side too. So they have been using this technology only on the anode side, but they are extending their capability for the cathode side, and then highly likely they start to get really big benefits out of it with the complete line, and the all other companies like all other incumbents in Korea are looking at this area too. So LG is highly likely the LG is this could be the second one who started the dry electric coating process. And there will be a bit of few other companies from Korea or Japan. But in China, they're just scouting because they don't have to do this. They are not really keen on changing their current capacity with the new technology because they already made a big plans for the future. So they cannot change it very easily. So the China is not that highly interested in this technology. And there are a few companies in Europe too who are interested. So the China, not really active, but Korea and European companies are very much interested in this technology. So I can see in a few years, you started to see this dry coating process in the manufacturing line in Europe and Korea.
Thanks.
That's something that I'm expecting now. Thank you.
We have a question online from Burak.
Yes. Yeah, thanks, by the way, for such a nice and insightful talk. So I actually have a question, or I'm curious about your opinion. So we all know that the batteries are now in their, let's say, first life. So now the next step, it will come the second life, and then the recycling will take over the batteries. So how do you see the potential on the recyclability on the Europe's position? Because from the beginning of your presentation, we had also see that the production capacity is pretty much related to the demand, the market demands. So
Absolutely.
how it will affect the recycling when it comes on the table? How the recycling could impact on Europe's, let's say, overall capabilities or overall competitiveness against?
That there are two pitfalls, because like the Europe wants to increase the whole capacity, that will end up with the large amount of scraps, or the second life battery, the end of life batteries you have to deal with. But the regulation is not following that way, high likely, because everybody's talking about like crushing or the burning, and this is just with the pyro methodology to make black masses or the mats. But you know what? To make a really recyclable, the circular use of the battery materials, then you really need a hydrometallurgical process. You really need a plant to do so. But there are only a few projects. So there is a huge discrepancy between what is really needed and what we can do here. So I'm always saying, like, we really need to build the hydrometallurgy plants within the area of the EU economical boundaries, because you cannot now. Currently, you can actually ship it outside the EU, ship the black masses, but they will ban the exporting the black masses outside Europe, and then now you created a lot of black masses, but you cannot do anything. So we really need to work on that. And secondly, but just making recycling is a good thing, but now more and more companies in Europe is thinking about using the LFP batteries because of cost parity, and also they have to push the market to adapt the more electric vehicles. But the LFP batteries cannot be really recycled. So there are two ways. You can find a way to recycle the iron phosphate somehow, or to reuse it as it is, which is not really feasible to me, but I know that there are some people or some institutes who are really working on it, including PAM. And that secondly, maybe just you can you can use other technology like middle nickel, bit nickel NCA or NMC, which could be as cheap as LFP, and then which is more recyclable. It makes more sense to recycle. So there are a bit of like discrepancy, so which I'm really concerned about. Could this be an answer to your question?
For sure. Thanks.
Thank you.
Thanks.
Thank you. Yeah.
John, thank you for the nice presentation. Since you're a materials expert, I just wanted to ask you, what's like in your experience, the material parameter or the material characteristics that typical machine suppliers forget about, or maybe should have a better understanding of?
But based on machines, so can you just specify the machine? Then I will try my best.
Okay. Let's stay with the coating or calendering of electrodes, because that's what the colleagues are developing.
Okay.
In the project. Yeah.
Okay, so the further coding, for instance, before coding, let me just talk until we can think about the process until when you finish coding. So the first is the slurries, because like again, you have to think about the parameters, which could be a bit different from what you may expect, because this is like not just mixing, right? You're dealing with your highly rheologically unstable slurries. With NMP is pretty okay, but without but some binders are not really good. Sometimes it creates the agglomerates. So it's not when it comes to the material parameters, high likely you are seeing that there's just like the viscosity or some rheological parameters, but you really have to control the concentration of certain materials which are fed by automated process. Very often they fail. So just please think about the accuracy of some added materials. The concentration would cause a big catastrophe in the rheological behavior. And the secondly, when it comes to the drying when it comes to the coating process, it's not only about the rheological process. You also have to think about there's actually the surface tension of these slurries, because even with the material with the same viscosity, they have a different profile when it's freestanding. I don't know how it can be like interpreted into the mechanical term, but sometimes the edge of the slurry goes crazy because you're actually coating a lot of materials at a really high speed, and sometimes you see they like a little bit crazy the edge profiles, and you don't want to do that, right? And thirdly the drying process, but for the drying process is pretty easy, and then you really have to think about the water consumption all the time. Just water. It's all about the water concentration.
Yeah,
Would it be
thank you.
helpful?
Yeah.
Or if you start to buy materials, just call me. That's going to be much easier, and then we can go through with all the properties. Thank you.
Yeah, thank you again for the talk and also for the nice discussion with the consortium and the participants.
Thank you. Then I was